Today, we are on the ground to see and truly understand the original location where this rock type was first described, revealing its fascinating role in Earth's geology. We'll blend geology with history as we talk about Dunite. Dunite is named after Dun Mountain near Nelson, New Zealand, for its brown dun color. Ferdinand von Hochstetter, an Austrian geologist, named it for the first time during the Novara expedition in 1859. He traveled to New Zealand as part of an expedition to map the geology of numerous countries. The brown color is jarringly obvious when you walk the trail and meet the mountain range for the first time. There is a clear line that extends all the way to the horizon. Here, vegetation suddenly stops, and the mountain begins. This is because almost all vegetation types cannot grow on magnesium-rich ultramafic rocks, which are igneous rocks very high in magnesium and iron, but low in silica. Dunite is originally green, but when exposed to the elements at the surface, it weathers and oxidizes, forming a super thin brown crust. This gives the mountain its brown, unappetizing color. For a rock to be classified as Dunite, it must contain more than 90% olivine with no quartz or feldspar. Chromite or magnesiochromite can sometimes occur as accessory minerals. Dunite forms deep underground and occurs within Earth's upper mantle. It is often found worldwide with serpentine deposits. Dunite appears to be exposed along major tectonic zones, where parts of the mantle are thrust upwards during tectonic collisions. Dunite forms as a reaction product of the melt and peridotite. It records magma's journey and acts as a firewall as it ascends. Because of olivine's high melting point and reactivity, we know these rocks formed deep underground and were uplifted relatively quickly on geological timescales. Understanding Dunite formation helps geologists better understand Earth's internal processes, as their presence at the surface is like a clue in a crime scene. The Dunite found at Dun Mountain has a staggering 97.5% olivine content, which makes it one of the most olivine-rich Dunites ever described. Magnesium-heavy chromite, a major chromium ore mineral, is the accessory mineral found within the Dunite at Dun Mountain. The presence of Dunite and other minerals, such as serpentine, has enabled the geologists to determine the geological history of the South Island of New Zealand. With these details, they pieced together a sequence of events that reveals the north part of the South Island of New Zealand is still being uplifted actively. The mountains around Dun Mountain are remnants of the mantle that are being rapidly uplifted, preserving their original mantle texture with parts undergoing low-grade metamorphism. In other words, Dunite is still being revealed at Dun Mountain and continues to shape the landscape today. In a surprising twist, Dunite has been found in samples within breccias returned by Apollo 14. In general, the olivine contained inside these samples is classified as an 89% forsterite olivine. The mission is famous for being the first to reach the highlands and for bringing back one of the most extensive geological collections from the moon. These rocks are still being studied by NASA and other scientists today. Though long dismissed as a plain brown rock, Ferdinand recognized the significance of Dunite in advancing our understanding of geology. Sometimes in life, countless people can pass by a simple can of soup and see only the metal can, missing the golden liquid contained inside completely. Just as Ferdinand recognized the hidden significance of Dunite, we must ask, what else are we missing by not looking closely? What future discoveries in mineralogy could change our understanding of the planet? One thing is certain, Mindex remains committed to exploring and sharing these discoveries with you. For more on everything about minerals, visit my channel, Mindex. Thank you for sticking to the end, and please do not forget to click the like and subscribe buttons. Peace out. Let's just jump there. Commented